Hi friends, this is Manikanta Prasanna Kumar. Welcome to my channel Maths with Money. You can follow me on my Facebook page Maths with Money. Regarding myself, I cleared RRB NTPC and also SSC CGL, and I am selected as Customs Inspector in CGL 2017. So friends, this is the part 3 of geometry revision formulas. So we already completed triangles, polygons and quadrilaterals also. So now in this video we will discuss circles, which is the last topic and lengthiest topic in geometry. So basically circles means it comprises of 4 subtopics. Okay, what are those topics? Basics of the circles and chords, next tangents, next pair of circles. These are the main 4 subtopics of the circles. So first we will start with the basics. So first, for suppose this is a circle of radius r. Then first point, perimeter of the circle is equal to 2 pi r. And before that we have another thing, diameter. Diameter means longest chord. Diameter of the circle is equal to 2 times of the radius. And next, area of the circle is equal to pi r square when radius is given. And when diameter is given, the direct formula to find out the area is pi d square by 4. And next, what about circles of equal area are congruent circles and concentric circles. If two circles have same radius, then they are called as congruent. When two circles have same center but different radii, then they are called as concentric circles. And area of the portion between those two circles is called area of the ring, and it is equal to pi of r2 square minus r1 square. Okay, and next we have some basic things in circles, that is arc, sector and segment. Suppose it is a circle, the portion of this circle is called as arc. Suppose it is a circle with center O and AB are 2 points, then the length of the smaller portion is called as minor arc, and this is a major arc. If a point C is in the major arc of the circle, then angle ACB is called as inscribed angle made by the arc AB, and AOB is the central angle made by the same arc AB. Now there is a property that the central angle made by the arc is always equal to the 2 times of its inscribed angle. If it is alpha, then what about this angle? 2 alpha. Okay. Next, what about the length of the arc? For suppose it is a circle with central angle with arc AB, and its in central angle is theta and radius of the circle is r. Then what about the length of the arc L? It is equal to 2 pi r into theta by 360 when theta is in degrees, and the length of the arc L equal to r theta when theta is in radians. Okay. Next, sector. Sector means portion of the circle. This is the minor sector and it is the major sector. So first, what is the perimeter of the sector? L plus R plus R. That is L plus 2R is the length of the perimeter of the sector. And what is the area of the sector? Area of the sector, we have so many formulas. If theta is in degrees, then pi r square into theta by 360. When theta is in radians, then of r square theta is the formula to find out the area of the sector, but theta is in radians. If theta is not given and only L and R is given, then area of this sector is equal to of LR. Of LR. These are the three formulas to find out the area of the sector. Next, segment. Segment means it is the region bounded by the chord and its arc. Suppose it is a circle with center O and radius is r and length of the arc is L. Then, and its central angle is theta. Then first, what about the perimeter of this segment, minor segment? I am talking about this segment. Perimeter of this segment. It is equal to L plus 2R sin theta by 2. And what about the area of this segment? It is equal to area of the sector minus area of this triangle. Yes, so pi r square into theta by 360 minus of r square sine theta. Of r square sine theta. So these are the small things regarding circles, that is arc, sector and segment. Okay. Next we'll discuss or we'll revise the properties of circles. So what about first property? Inscribed angle is alpha, then its central angle is 2 alpha. What about second property? All these are basic properties, very basic. Angle in the semicircle is always 90 degrees. Is always 90 degrees. And what about third property? Angle in the same segment of a circle are equal. This and this, both are equal. Okay. These are the three basic properties of the circles. Next thing is, an important model in circles is, for suppose there is a circle and a triangle is inscribed in it, or this is the circumcircle of this triangle, because all the vertices passing through the circle. Now, if the angular bisectors of these triangles intersect these circles at P, Q, R. Okay. If I join these points, definitely I'll get a triangle. Yes or no? Now, what about the angles of this triangle PQR? That is, angle P equal to 90 degrees minus A by 2. 90 degrees minus A by 2. Because P is the vertex which is opposite to A. Yes, that's why 90 minus A by 2. Similarly, can you tell me the value of angle Q? Angle Q equal to 90 minus B by 2. Because opposite to Q is B. Similarly, angle R equal to 90 minus C by 2. These are also very, very important. If you remember directly, then you can put the answer in very quick time. These are the basics. Okay. Next topic is chords. Chords. So chord means it is a line joining any 2 points of a circle. So first we will discuss some basic properties of chord. Suppose it is a chord AB, okay, and O is the center. So if I draw the perpendicular drawn from the center, definitely it bisects the chord. And length of the chord is equal to, length of the chord L is equal to, if the distance from the center to the chord, perpendicular distance is small d, and R is the radius, then it is equal to 2 times of R square minus D square. If D is not given, but the central angle made by the chord is given, if this angle is given theta, then length of the chord is equal to 2R sine theta by 2. This is the first formula you have to remember from the chord. Okay, and this perpendicular drawn from the center is always angular bisector of the central angle. So these two angles are also equal. Next property. Equal chords are always equidistant from the center. Suppose these two are equal chords, then the distance between the center to these chords are always equal. If chords are equal, then the distance from the center are equal. If the distances from the center are equal, then the chords are always equal. Okay. And if there are two chords, there are not equal chords, they are unequal. Okay. And their lengths are L1 and L2. If the central angle made by the first chord is theta 1 and central angle made by the second chord is theta 2, then L1 by L2 is equal to sine of half of the angles theta 1 by 2 by sine of theta 2 by 2. We already discussed all these formulas in circles paid course with proofs. Okay. So if anybody has doubt, please purchase that circles paid course. Okay, so these are the basic properties, and one more basic property is parallel cards drawn from the extremities of diameter are always equal. Suppose it is a diameter, from the ends of the diameter or the extreme points of the diameter, if I draw two parallel cards like this, okay, then they are not only parallel, they are always equal. Okay, this is another property. Now we will discuss parallel cards. Cards means we have three types. One is parallel cards, perpendicular cards, or next intersecting. So if the angle between the intersecting lines is 90 degrees, then the cards are called as perpendicular cards. That's it. So for each type of cards, we have some different properties. Let's see. First, parallel cards. Parallel cards means if the cards never intersect, for suppose it is one card and it is another card, these two are parallel to each other. So in parallel cards we have two types. What are those two types? Cards are on the same side of the center, or cards are on either side of the center. In the first case they are same side of the center. In the second case they are either side of the center. Okay, it is same side and it is either side. If the radius of the circle is r and length of the cards are 2a and 2b, not a and b, 2a and 2b, okay, and distance between the cards, okay, 2a and 2b, and radius of the circle is r, then if same side of the center, the cards lie on the same side of the center, it is the distance between the cards. Okay, and in the either side of the case, the distance between the center, distance between the cards is this. Okay, is it clear? Now we have few things to remember. If the distance between the center to the first card is x and distance from center to the second card is y, now tell me what is the distance between the cards here? X difference of y. X difference of y. In the second case, if distance from the center to the first card is x and distance from the center to the second card is y, then what about distance? It is equal to x plus y. Addition of these two distances, and here difference of the distances. So now I'll write down here directly. So distance between the cards, if same side is there, x difference of y, that means r square minus a square under root difference r square minus b square. If d either side, then it is x plus y, it is equal to r square minus a square under root plus r square minus b square under root. Okay, but in the exam we have one particular model. What is that particular model? R radius and half of the cards, half of the length of the cards forms a triplet, that is r square equal to a square plus b square. Whenever this condition is there, then d equal to distance between the cards is equal to sum of the half of the lengths of the cards when either side is given, and it is equal to difference of the half of the lengths of the cards when same side is given. Directly you can remember these values. Is it clear? So it is one of the most important property in case of parallel cards. That's it. Next, intersecting cards. Intersecting cards. Here we have circle with center O, and these are the two cards AB and CD. For suppose they intersect at some point P. In intersecting cards we have two types, internal and external. When the cards intersect inside the circle, they are called as internal, and when the cards intersect externally, like this, I'll draw a diagram for this. Suppose it is a circle with center O, and these two are the cards. They are not parallel cards, AB and CD. They are not intersect inside the circle, but they intersect outside the circle. Okay, then these are also said to be intersecting cards, but they are called as external intersecting cards. So first we will discuss internal intersecting cards. With center O and this cards AB and CD intersect at some point E. E or P, whatever it may be. I'll take it as P. Okay. So first point here you have to remember PA into PB equal to PC into PD. Product of the distances from the intersection point to the extremities of the card are equal. And next, APC and BPD both are equal now. So angle APC and angle BPD both are equal to. Here I am taking APC, that means this card sector, it's not sector, this arc, and BPD, it represents this card, this arc. Okay, so which is equal to the half of central angle made by these arcs. Central angle made by these arcs means half of angle AOC plus angle BOD. For suppose if I want angle BPC means this angle, or which is also equal to this angle APD. Both are vertically opposite angles. If I talk about this angle BPC means what about opposite arc BC? And for this, what is the arc AD? Yes. So which is equal to half of the sum of its central angles central angles made by those arcs, angle BOC plus angle AOD. Okay, please remember these formulas directly. Okay, and one more thing, there are two cards but they are equal cards having same end point. One end point is same. Suppose AB and AC are two equal cards, then the line joining this point to the center is always angular bisector of this point. If I draw or if I join this point and the center, definitely this line becomes the angular bisector at the vertex A. Okay. Next, external intersecting cards. These are two cards. Okay, they intersect externally. AB and CD intersect at P. Then first point, PA into PB, same product of the distances from intersection point to the extreme points of the card are equal. PA into PB equal to PC into PD. Next, in the similar manner of internal, angle APC, which is same as BPD, both are equal to half of APC means this arc, BPD means this arc. Yes, so half of difference of the central angles made by those arcs, AOC minus B angle BOD. In case of internal, we have to take plus, but in case of external, we have to take a difference minus. Is it clear, all of you? Friends, చిన్న బ్రేక్ అనుకోండి, ఇది ఏం లేదు, మీకు సర్కిల్స్ అనే కాన్సెప్ట్ అనేది 20 వీడియోస్ లో చెప్పడం జరిగింది అండ్ మొత్తం 22 hours అండ్ ద కాస్ట్ ఈస్ 200 rupees. సో దిస్ ఈస్ ద పెయిడ్ కోర్స్. సో మనం బేసిక్ గా జామెట్రీ అండ్ 2D మెన్సురేషన్ ఫ్రమ్ పాయింట్ దట్ ఈస్ లైన్స్ అండ్ యాంగిల్స్ నుంచి పాలిగాన్స్ వరకు చాలా క్లియర్ గా చెప్పడం జరిగింది. ఇన్ ద సేమ్ వే సర్కిల్స్ కూడా కవర్ చేశాను, బట్ ఇట్ ఈస్ పెయిడ్ కోర్స్. అండ్ మనం దాంట్లో ఎన్ని ప్రాబ్లమ్స్ కవర్ చేసాము అనేది చూసుకుంటే, సో చూడండి, మనకి ప్రతి కాన్సెప్ట్ కూడాను ప్రాక్టీస్ ప్రాబ్లమ్స్, అలానే 2011-18 CGL మెయిన్స్ క్వశ్చన్స్ కూడా డిస్కస్ చేయడం జరిగింది టాపిక్ వైస్. ఓకే, సో 29 క్వశ్చన్స్, 40, 43, 56 టోటల్ 168 క్వశ్చన్స్ దాకా చెప్పాం. అండ్ టోటల్ నెంబర్ ఆఫ్ అవర్స్ ఇస్ 22 hours. సో మీకు ఇక్కడ ప్రాబ్లమ్స్ చెప్పే ముందు ప్రతి టాపిక్ కూడా ఫుల్ కాన్సెప్ట్ అనేది చెప్పడం జరుగుతుంది క్రిస్టల్ క్లియర్ గా. ఓకేనా? సో మీకు ఈ మొత్తం వీడియో కోర్సెస్ తో కావాలి అంటే 200 rupees. అలా కాదు ఓన్లీ ఈ క్వశ్చన్స్ కి సంబంధించిన పీడిఎఫ్ కావాలి అంటే ఇట్ ఈజ్ ఓన్లీ 40 రూపీస్. ఓకేనా, టోటల్ 166 ప్రాబ్లమ్స్ విత్ కీ మాత్రమే ఉంటుంది. నో సొల్యూషన్స్ ఆర్ ప్రొవైడెడ్ విత్ దిస్. కీ విల్ బి దేర్. The practice problems and also CGL mains questions on these particular topics. ఓకే, ఈ కోర్స్ మీరు తీసుకోవాలి అనుకునే ముందు మీకు డెమో వీడియోస్ అనేవి 3 ఉంటాయి. ఓకేనా, one is on perpendicular chords and another one is on secants and another one is on pair of circuits. ఓకేనా, ఈ 3 డెమో వీడియోస్ చూడండి, చూసాకే తీసుకోండి. ప్రతి టాపిక్ కూడా లైక్ దిస్ చూడండి. మీకు సర్కిల్స్ బేసిక్స్ తీసుకున్నారు అనుకోండి, ప్రతి దాని మీద కూడా మీకు 4 వీడియోస్ ఉంటాయి. పార్ట్ 1, పార్ట్ 2, పార్ట్ 3, పార్ట్ 4. ఏంటేంటి అంటే ప్రాపర్టీస్ అంటే కాన్సెప్ట్ చెప్పడం జరుగుతుంది, అండ్ ప్రాబ్లమ్స్ అనేది 1 or 2 వీడియోస్ లో ఉంటుంది, అండ్ 4th వన్ అండ్ లాస్ట్ వన్ ఈజ్ మెయిన్స్ క్వశ్చన్స్, ప్రీవియస్ మెయిన్స్ క్వశ్చన్స్ డిస్కస్ చేయడం జరుగుతుంది. అలానే మనం ప్రతి టాపిక్ కూడా చెప్తాం, కార్డ్స్ కానీ అదర్వైజ్ ఇన్ టాంజెంట్స్ అండ్ సీకెంట్స్ లో కానీ. ఓకే, అండ్ పెయిర్ ఆఫ్ సర్కిల్స్. మోస్ట్ ఇంపార్టెంట్ టాపిక్ ఇన్ సర్కిల్స్ ఈజ్ పెయిర్ ఆఫ్ సర్కిల్స్. అందువల్ల మనం పెయిర్ ఆఫ్ సర్కిల్స్కే మనం కాన్సెప్ట్ చెప్పడానికి 3 వీడియోస్లో నేను చెప్పాను. ఓకే, అండ్ ఫర్ ప్రాబ్లమ్స్ చూసుకునేసరికి 2 వీడియోస్ ఫర్ ప్రాక్టీస్ ప్రాబ్లమ్స్ అండ్ 2 వీడియోస్ ఫర్ ప్రీవియస్ క్వశ్చన్స్. ఇలా మనం మొత్తం కూడా డిస్కస్ చేయడం జరిగింది. సో ఎవరైతే ఈ సర్కిల్స్ కోర్స్ తీసుకోవాలనుకుంటున్నారో వాళ్ళు ఎలా పర్చేజ్ చేయాలి అంటే గూగుల్ పే కానీ అదర్వైజ్ ఫోన్ పే కానీ. ఓకే, నెంబర్ అనేది 9490882754. ఈ నెంబర్కి మీరు ఆ అమౌంట్ పర్చేజ్ చేస్తే 200 రూపీస్ ఫర్ కోర్స్ అండ్ 40 రూపీస్ ఫర్ పీడిఎఫ్. ఆ పీడిఎఫ్ అనేది ఆటోమేటిక్గా కోర్స్ తీసుకున్న వాళ్ళకి ఇస్తాం. ఓకేనా, మీరు ఓన్లీ పీడిఎఫ్ కావాలి అంటే 40 రూపీస్ పే చేయండి. అదర్వైజ్ లేదు మా కోర్స్ కావాలంటే కోర్స్లోని ఆల్రెడీ పీడిఎఫ్ అనేది ఇంక్లూడ్ అవుతుంది. ఓకేనా, అండ్ ఈ కోర్స్ పర్చేజ్ చేసేవాళ్ళు అంటే వీడియో కోర్స్ పర్చేజ్ చేసేవాళ్ళు మాత్రం ఖచ్చితంగా మీ మెయిల్ ఐడి అనేది ఖచ్చితంగా ఈ నెంబర్కి వాట్సాప్ చేయాలి. సో ఆ మెయిల్ ఐడిని యాడ్ చేయడం జరుగుతుంది. దెన్ ఓన్లీ యూ కెన్ వాచ్ దోస్ వీడియోస్. ఓకేనా, సో నౌ విల్ గో టు ది మెయిన్ వీడియో. నెక్స్ట్ ఈజ్ perpendicular chords. Most important in the chords is perpendicular. Direct models will be given. So the first model in perpendicular chords means if the intersecting chords makes an angle 90 degrees at intersection point, then those chords are perpendicular. Okay, if it is AB and it is CD, and the circle radius is R. Okay, and if the lengths of the chords are 2A and 2B, and the distance from the center to the intersection point is some C, then radius of the circle equal to A square plus B square plus C square by 2 under root. Okay, this is one important model. What are given? 2A and 2B are the length of the chords, not A and B, and C is the distance from center to the intersection point. Then radius of the circle is A square plus B square plus C square by 2 under root. Total ki root ఉంటుంది. Okay, next second model. There is a circle with center O and 2 chords AB and CD intersect at some point P. Okay, if the distances from intersection point to the end points of the chords, that is PA is A, PB is B, PC is C and PD is D, then radius of the circle is equal to A square plus B square plus C square plus D square under root by 2. There is not square root for 2. Okay, this is first point. Second point, if BC and AD length is given, if BC and AD length is given, for suppose it is some X and for suppose the length of AD is some Y. Okay, or for suppose this length BD is some length P and for suppose this length Q is given, then radius of the circle is equal to P square plus Q square under root by 2 or X square plus Y square under root by 2. What values are given? Based on those values you can find out the radius or diameter, whatever it may be. Is it clear? Next, third model. For suppose here not only perpendicular chords, they are perpendicular diameters. Okay. Suppose it is one diameter and it is another diameter. Both diameters passes through center, of course, and both the diameters are perpendicular diameters. Is it clear? Now there is a line, some line. There is a line MN. Sorry, 1 minute. If you join any 2 points, for suppose AC or BD, whatever you have to join, any adjacent points if I join, for this line, if I draw a line which is parallel to this line, suppose there is a line MN which is parallel to DB. Okay, and if that line intersects the diameter at P and Q. Okay, if MP is some P and NP is some Q, then radius of the circle R equal to square root of P square plus Q square by 2. Square root of P square plus Q square by 2 under root. So this is another important model in perpendicular chords. And next model, that is fourth one, it is also important. For suppose AB and CD are two perpendicular chords like this, AB and CD intersect at 90. O is the center. Then AOD plus angle BOC. Angle AOD plus angle BOC is equal to 180 degrees, or angle AOC plus angle BOD equal to 180 degrees. That means if this is alpha, that it is theta 1, theta 2, theta 3 and theta 4, then sum of the opposite angles theta 1 plus theta 3 equal to theta 2 plus theta 4 equal to 180 degrees. This property holds for only perpendicular chords. Is it clear? That's it. Next is tangent. Tangent means it is a line joining from an external point to the circle, and if it intersects at only one point. Okay. So for suppose it is a tangent drawn from an external point to the circle. If it intersects at point some it is O and it is suppose P, and if it is E. Okay, this is an external point. Then the length of the tangent AP, is equal to how much? D square minus R square. What is a D? D is a distance from center to the external point, and OP is R, that is radius. And one more thing, tangent is always perpendicular to the radius. AP is always perpendicular to the radius OP. Next, number of tangents based on the external point. If suppose the external point lies outside, then how many tangents you can draw? 2 tangents. If the external point lies on the circle, then we can draw only 1 tangent. If the external point lies inside the circles, we cannot draw any tangent. 0 tangents can be drawn. Okay. Like chords, in the tangents also we have 3 types. What are those? Parallel, intersecting and perpendicular. If the tangents intersecting at 90 degrees, then those tangents are called as perpendicular tangents. That's it. Let's see, first talk about parallel tangents. Suppose it is a circle with center O, and this is one tangent. Oh shit. Okay, there is, oh, I'll draw correctly. Okay, don't do that, because we'll draw a circle first. Okay, this is a circle, and now I'll draw a line. These blue lines are always parallel tangents. Here the first point is tangents drawn at the extreme points of the diameter are always parallel. For suppose it is A and it is B and it is O. Center is O. AB is the diameter. The tangents passing through the extreme points of the diameter are always parallel. If the tangents are parallel, then the first one, the distance between the tangents is always equal to diameter of the circle. And one more thing is, for suppose there is another tangent, observe this. There is one more tangent which is not a parallel tangent to the given tangents, but it intersects the given parallel tangents at points C and D. Then angle COD is always equal to 90 degrees. Most important point. Angle COD equal to how much? 90 degrees. And if OC is equal to A and OD equal to B, then radius of the circle, if R is the radius of the circle, then 1 by R square equal to 1 by A square plus 1 by B square. And if this CD tangent intersects the circle at some E, and if CE is X and DE is Y, then radius of the circle is equal to root over XY. So based on the values given, you have different relations. What are A and B? These are the distances from center to the points of intersection of the parallel tangents with the intersecting tangent. And what about X and Y? These are the distances from the point of contact of the circle to the point of intersection of the parallel tangents. Okay, is it clear? If CD, this line CD is also parallel to AB, if it is parallel to AB, then CD and AB both are equal. CD and AB are equal. So this is about the parallel tangents. So these properties are enough in case of parallel tangents. Next is intersecting tangents. It is important. When tangent intersect at some point, so I will draw clearly, then you can easily understand. Okay, let's see. This is a circle and this is one tangent and this is another tangent. They intersect at this point. Okay. PA and PB are two intersecting tangents of a circle with center O and radius R. Then first point is both the tangents are equal. PA and PB are equal. Tangents drawn from an external point to the circle are always equal. PA and PB are equal. And the next one is the line joining the external point with the center becomes the angular bisector at the external point. So these two are equal. If it is alpha, this is also alpha. And not only this, if I join AB becomes the chord. Yes. If this is alpha, then it is also alpha. Not only that, these two are also alpha. That means angle APO is equal to angle BAO. Angle APO and angle BAO are also equal. So it is also alpha, it is also alpha. And this angle is 90 degrees. Okay, that means PO is perpendicular to AB. And AC and BC are equal. If it is C, these two are also equal. These two are also equal. That means C is the midpoint of AB. And last point is APBO forms a cyclic quadrilateral. That means angle P plus angle O is equal to 90 degrees, that is 180 degrees. APB plus angle AOB. We already discussed in cyclic quadrilaterals. Whenever sum of two opposite angles is 180, then the quadrilateral is cyclic. So here angle APO and AOB is equal to 180 degrees. These are some basic properties in intersecting tangents. Now we will discuss or we will revise some basic models, important models in intersecting tangents. For suppose it is a circle and these are the two tangents drawn from the external point PA and PB. If angle between the tangents it is 2 alpha, okay, and it is the center O. Now tell me what is angle AOB. Since sum of these two angles is 180, so if it is 2 alpha, then first point angle AOB is 180 minus 2 alpha. Now, if I take any point on the major arc, then tell me angle ACB, if I suppose it is C, angle ACB equal to half of the inscribed angle, 90 minus alpha. Next, if I take any point in the minor arc, if I take minor arc, in the minor arc, then angle ADB equal to 90 plus alpha, 90 plus alpha. Because since it is 90 minus alpha, ACBD forms a cyclic quadrilateral. So sum of these two angles is 180. Okay. Whenever in the exam, suppose there is a figure like this. AB and AC are two tangents drawn from the external point, and if the angle between these two tangents is 70 degrees, and here there is a point D is given. Now tell me what about this angle? It is the point in the minor arc. So what is angle BDC? It is equal to 90 plus alpha. What is alpha? 70 by 235. So 125 degrees. Within seconds you can easily solve it. That's it. Okay. Next important model. I will draw it. There is a circle like this. Okay. And these are the tangents drawn from the external point. So definitely they are equal. Now there is another tangent which intersects the given tangents at 2 points. Okay. Suppose PA and PB are two tangents drawn from the external point P, and X and Y, XY is a tangent which intersects the circle at some point T. Okay. Now, if the angle between the tangents is 2 alpha, then first point is perimeter of triangle PXY. Perimeter of triangle PXY, this triangle. PXY is equal to sum of the tangents PA plus PB, or P and PB both are equal, so I can write 2PA or 2PB. It is the first important point. Next, second thing, if angle between the tangents is 2 alpha and it is the center O, now XOY, angle XOY is a 90 minus alpha. 90 minus alpha. Okay, that is very important. Angle AOB is 180 minus 2 alpha, but XOY is 90 minus alpha. That's it. These 2 points are very important. And next one is relation between tangent and chord, that is alternate segment theorem. Alternate segment theorem. What is alternate segment theorem? There is a circle, and if it is a chord AB, it intersects the circle at T. The point of contact is T. Now, if I take any chord drawn from this point T, TC. Now, angle between the tangent TB and the chord is theta, then the angle made by this chord in the alternate segment is also equal to angle made by the chord and tangent. If this angle is theta, then this is also theta. If this angle is alpha, it is a tangent, and TD is chord, this is equal to angle made by this chord in the alternate segment, so it is also alpha. This is about alternate segment theorem. Okay. Next is secants. Secant means it is a line drawn from the external point of the circle, and if it intersects the circle at 2 points, then we call it as secant. Okay. So properties of secants are it is nothing but these are external intersecting chords. For suppose if I take PAB and PCD are two secants drawn from the external point P. We can also tell it as BA and DC are two chords, and these two chords intersect at point P outside the circle. That's why we can call secants, two secants drawn from external points are same as externally intersecting chords. So what is the property we have here? PA into PB equal to PC into PB. Okay. But there is one more relation between tangent and secant. Suppose it is center O. From an external point P, I draw a secant. From the same external point, if I draw a tangent to the circle, then square of the tangent equal to PA into PB. PT square equal to PA into PB. Very, very important. Okay. Next. These are some models in chords or external intersecting chords, or we can also discuss in secants. What is that? For suppose these are two secants PAB and PCD, and it is center O. Center. So center means here, center O. If angle between the secants is some P and this angle is Q, okay, and if this angle is alpha and if this angle is beta, then P plus Q equal to alpha plus beta. P plus Q is alpha plus beta. Is it clear? All of you? For suppose BD is a diameter. BD is diameter. Same thing I am applying here. Suppose it is the circle and BD is the diameter. BD. Same PAB and PCD are secants. PAB and PCD are secants. Okay. And angle between the secants is P. And angle AOC is Q. Then P equal to 90 minus Q by 2. P equal to how much? This angle between the secants is 90 minus Q by 2. Direct formulas. I told you proofs in the paid course. But I am now here, we are only revising the formulas. Okay. So based on the diagram, you have different formulas. If you remember the formula, we can solve it in very less time. Next, there is one more formula I told you. Circle with center O and PAB and PCD are two secants, PAB and PCD, and angle between the secants is some P and AOC is Q. Okay. If B and C is joined and A and D is joined, now the angle between the chords AD and BC is alpha, then alpha equal to P plus Q. Very, very nice model. Alpha equal to P plus Q. Out of these three variables, two are given and you have to find out the other variable. These are some basic properties or main important properties with models in circles, basics and chords and tangents and secants. Friends, again a small break. So సర్కిల్స్ లానే మనం మెన్సురేషన్ 3D పెయిడ్ కోర్స్ కూడా చెప్పడం జరిగింది. సో టోటల్ 3D మెన్సురేషన్ ఎవ్రీ టాపిక్స్ చూసారు ఇక్కడ మనకి ప్రిజమ్స్ నుంచి రిమూవల్ ఆఫ్ ఎర్త్ ఈ ప్రతి టాపిక్ వైజ్ ప్రాక్టీస్ ప్రాబ్లమ్స్ అంటే కాన్సెప్ట్ చెప్తూ నెక్స్ట్ ప్రాక్టీస్ ప్రాబ్లమ్స్ అలానే CGL 2011 టు మెయిన్స్ క్వశ్చన్స్ అలాంటివి డిస్కస్ చేయడం జరుగుతుంది. సో ఓవరాల్ గా ఇది మనకి 40 వీడియోస్ లో చెప్పడం జరిగింది. సారీ 44 వీడియోస్ అండ్ 44 hours. ఓకే అండ్ టోటల్ కాస్ట్ ఈస్ 500 రూపీస్. సో మొత్తం ప్రాబ్లమ్స్ ఎన్ని డిస్కస్ చేసామంటే కాన్సెప్ట్ కాకుండా 323 ప్రాబ్లమ్స్ అనేవి డిస్కస్ చేయడం జరిగింది. సో ఇప్పుడు ఈ 323 ప్రాబ్లమ్స్ PDF మాత్రమే కావాలనుకుంటే దిస్ కాస్ట్ అబౌట్ 50 రూపీస్. అంటే మీకు ఓన్లీ నెంబర్ ఆఫ్ క్వశ్చన్స్ ఆ PDF క్వశ్చన్స్ విత్ కీ ఓన్లీ కీ మాత్రమే ప్రొవైడ్ చేయడం జరుగుతుంది, సొల్యూషన్స్ కాదు. ఓకేనా, ఇవన్నీ కూడా టాపిక్ వైజ్ చెప్తున్నాం. అలానే మీకు టాపిక్ వైజ్ సెగ్రిగేట్ చేసి ఇవ్వడం జరుగుతుంది. అలా కాదు మీరు కోర్స్ తీసుకోవాలంటే 500 రూపీస్. అండ్ చూడండి ఈ కోర్స్ తీసుకునే ముందు మీకు 11 డెమో వీడియోస్ ఉన్నాయి. పిరమిడ్ ఫార్మ్డ్ బై కటింగ్ ఆఫ్ క్యూబ్ అండ్ సిలిండర్స్ లో 2D to 3D ట్రాన్స్ఫర్మేషన్ and largest sphere inscribed in a tetrahedron, cone formed by folding of a sector, and largest sphere inscribed in a cone inscribed in a cylinder, largest cone inscribed in a sphere, and cutting of sphere, and last three are cuboid and cube in a hemisphere, and pyramid or cone drilled from a solid figure, and volume of the water that can just immerse the ball. These are the 11 demo videos I am providing you for free. ఈ వీడియోస్ అన్నీ కూడా మనకి మెయిన్ కోర్సులో కూడా చెప్పడం జరుగుతుంది. ఈ వీడియోస్ చూసి మీకు 3D మెన్సురేషన్ అవసరమా లేకపోతే ఈ లెవెల్ ఆఫ్ క్వశ్చన్స్ మీకు తెలియవు అనుకున్నా కూడా ఖచ్చితంగా కోర్స్ తీసుకోవచ్చు. ఓకేనా, ఈ కోర్సులోని ప్రతి టాపిక్ కి అంటే సబ్ టాపిక్స్ ఏవైతే ఉన్నాయో వాటిలో 4 వీడియోస్ అనేవి ఉంటాయి. ఒకటి ఫుల్ కాన్సెప్ట్, దానికి సంబంధించిన కాన్సెప్ట్. ఇన్స్క్రైబింగ్ ఫిగర్స్, దిస్ ఈస్ ద మోస్ట్ ఇంపార్టెంట్ కాన్సెప్ట్ నౌడేస్ 3D మెన్సురేషన్ లో ప్రతి టాపిక్ కి చెప్పడం జరుగుతుంది. అండ్ నెక్స్ట్ ప్రాబ్లమ్స్ అంటే ప్రాక్టీస్ ప్రాబ్లమ్స్ అండ్ ప్రీవియస్ మెయిన్స్ క్వశ్చన్స్, ఇలా 4 వీడియోస్ గా ప్రతిదీ చెప్పడం జరుగుతుంది. ఫర్ సపోజ్ దట్ కాన్సెప్ట్ ఈజ్ మోర్ ఎక్కువ టైం తీసుకుంటుంది అంటే కాన్సెప్ట్ ని మళ్ళీ 2 వీడియోస్ లో చెప్పడం జరుగుతుంది. ఇలా ప్రిజమ్స్ కి అంతేకాకుండా క్యూబాయిడ్స్ కి క్యూబ్స్ కి నెక్స్ట్ సిలిండర్స్ అనేది కొంచెం లెందీ టాపిక్ కాబట్టి ఇట్ టుక్ 7 వీడియోస్. అండ్ పిరమిడ్స్ అండ్ ఆల్సో కోన్స్ కూడా కొంచెం లెందీ టాపిక్. అండ్ నెక్స్ట్ స్పియర్స్ అండ్ హెమిస్పియర్స్ అండ్ ఆల్సో ఎక్స్ట్రా టాపిక్స్. అవి కాకుండా మనకి ఇలా ఎక్స్ట్రా టాపిక్స్ ఉంటాయి. రిమూవల్ ఆఫ్ సాలిడ్ ఫిగర్ అండ్ రేట్ ఆఫ్ ఫ్లో అండ్ ఇంక్రీజ్ ఇన్ వాటర్ లెవెల్ అండ్ ఫిల్లింగ్ ఆఫ్ ల్యాండ్ ఆర్ సాయిల్ టేకెన్ ఫ్రమ్ ది సమ్వేర్. ఓకే, సో ఇవన్నీ కూడా మనకి ఎక్స్ట్రా టాపిక్స్ కింద ఉంటాయి. టోటల్ 44 పార్ట్స్ 44 వీడియోస్ లో మనం చెప్పడం జరిగింది. సో కాబట్టి ఎవరైతే ఈ 3D మెన్సురేషన్ డౌట్ ఉందో వాళ్ళకి బేసిక్స్ నుంచి ఫుల్ లెంత్ కాన్సెప్ట్ అనేది చెప్పడం జరుగుతుంది. కాబట్టి ఈ కోర్స్ ఖచ్చితంగా యూజ్ అవుతుంది. అండ్ ద టోటల్ కాస్ట్ ఈస్ జస్ట్ 500 రూపీస్. PDF మాత్రమే కావాలంటే 50 రూపీస్. ఈ 500 రూపీస్ కోర్స్ తీసుకున్న వాళ్ళకి 50 రూపీస్ PDF అనేది ఖచ్చితంగా ఇవ్వడం జరుగుతుంది. ఓకే, ఎలా మీరు పర్చేజ్ చేయాలంటే లైక్ సర్కిల్స్ కోర్స్ లానే ఫోన్ పే కానీ గూగుల్ పే కానీ ఏ నెంబర్కి చేయాలమ్మా, సేమ్ నెంబర్ 9490882754 కింద స్క్రోల్ అవుతున్న నెంబర్ కూడా ఇదే. ఈ నెంబర్కి మీరు అమౌంట్ పే చేసి ఆ స్క్రీన్ షాట్ ని ఈ నెంబర్కి వాట్సాప్ చేయండి. అలానే మీ మెయిల్ ఐడి అనేది ఖచ్చితంగా ఇవ్వాల్సి ఉంటుంది. ఓకేనా, సో మీకు మెన్సురేషన్ 3D అనేది చాలా చాలా ఇంపార్టెంట్ ఈవెన్ ఇఫ్ యూ ఆర్ ప్రిపేరింగ్ ఫర్ DO మెయిన్స్ ఆర్ SSC CGL. Okay, now we'll go to the main video. Next and last subtopic in circles is pair of circles. Pair means two. Okay, we have different models in pair of circles. What are those? Non-intersecting circles, next intersecting circles, concentric circles, internally touch each other circle, externally touch each other circles. These are the 5 important models in pair of circles, 5 important types. For each type we have different formulas and we have different models and we have to revise all the things before the exam. So before starting with any type, first I have to tell you common tangent. When a tangent is common to both the circles, given 2 circles, then it is called as common tangent. Direct common tangent means If the circle lies on same side of the center, then it is called as direct. If the circle lies either side of the tangent, then we call it as transverse common tangent. For each type of circles, we have number of direct common tangents. We have how many direct common tangents or how many transverse common tangents will exist. We have to discuss that also. Let's see. First pair of circles is concentric circles. Concentric circles. Concentric circles means we already discussed in circles basics only. They have same center but different radius. So in that, first one is how many direct common tangents exist. First, how many common tangents exist? Zero. Zero, because if I draw a tangent for the outer circle, then it is not a tangent to the inner circle. If I draw a tangent to the inner circle, then it is not a tangent to the outer circle. It becomes the chord of the circle, chord of the outer circle. So that's why number of common tangents is 0. If common tangents is 0, then need not discuss anything about direct and transverse common tangents. Second point is the length of the tangent or length of the chord of the bigger circle, which is tangent to the inner circle. Okay, that is the length of the chord, longest chord, which is length of the longest chord of the bigger circle, which is tangent to the inner circle, AB equal to 2 times of R2 square minus R1 square. And what about the distance between the centers? Since they have same center, distance between the centers is 0. These three formulas are sufficient in concentric circles. Next type is non-intersecting circles. Non-intersecting circles means like this. If it is R1 and it is R2 and these are the centers O and O dash, and it is the distance between the centers. So in non-intersecting circles, first point is the distance between the centers is always sum of the radii, and second point is number of direct common tangents. So first, number of common tangents is equal to 4. Out of 4, 2 are direct and 2 are transverse. 2 direct, 2 transverse. Okay now? Next, if the transverse, first we will discuss about direct common tangents. Okay, the properties, length of the direct common tangent and what are the formulas in direct common tangent. So first, these are the two circles and these are the direct common tangents. So direct common tangents basically not intersecting, but when I extend them, then definitely they intersect at some point. If AB and CD are two direct common tangents and they intersect at some point P, and O dash are the centers of the given circles, then the first point is O dash and P are collinear. That is the first point. Second point, length of the direct common tangent. Here both direct common tangents are equal. Okay, AB and CD. AB and CD are equal to square root of d square minus difference of the radius whole square. R1 and R2 are the radii of the given circles. Okay. Next, the intersection point of the tangents, direct common tangents, divide the line joining the centers in the ratio of R1 is to R2, but externally. That is PO by PO dash. Here I am writing. Remember, PO by PO dash equal to R1 by R2. Or PA by PB is also equal to R1 by R2. Or PC by PD is also equal to R1 by R2. This ratio is important. Okay. Once again, I am drawing here. Suppose this is a circle. This is another circle. The radius is R1 and it is R2. And Now I'll tell you some 4 formulas. Both are very, very important. It is O and it is O dash, and it is A and it is B and it is P. Okay, and the distance between the centers is D. And AB is nothing but length of the direct common tangent. We already discussed that formula. Okay, what is that? Square root of D square minus R1 minus R2 whole square. Now we have some other formulas. No one will tell you these formulas. Remember them. First formula, PA, distance from the intersection point of the tangents to the first circle. PA, tangent PA is equal to, here you are taken from external point the first circle. So what is the first circle radius? R1. Since we are discussing about direct common tangent formulas, definitely you have to take the difference of the radius. So R1 minus R2 into this PA is the extended part of AB. Yes, so into LDCT. So similarly, can you tell me the value of PB? It is for the second circle R2 by R1 minus R2 into LDCT. If I talk about the PO, this value, okay, PO means PO for the first circle, yes, so R1, and we are discussing about the direct common tangents R1 minus R2 into PO is on the extended part of the distance between the center, so into D. Similarly, PO dash is R2 by R1 minus R2 into D. So these are the 4 formulas, please remember, then you can definitely solve the problems in a very, very quick time. Next, properties of transverse common tangent in non-intersecting circles. First, suppose these are the 2 circles, O dash, and it is R1 and it is R2 radius. Now, these two are the transverse common tangents. Okay, if they intersect at some point P, then O dash are collinear. O dash are collinear. Okay, and distance between the centers is D. And the length of each transverse common tangent, for suppose AB and CD, both are equal, and both are equal to how much? D square minus R1 plus R2 whole square. When we talk about the formulas of transverse common tangent, you have to take the sum of the radius. Okay, here also same formulas, PO by PO dash. Here the point of intersection of the transverse common tangents divide the line joining the center in the ratio of R1 is to R2, but internally. So what I can write, PO by PO dash is equal to R1 by R2, which is same as PA by PB, or which is same as PC by PD also. Okay, next, same points, we have 4 formulas in direct common tangent. Same manner, we have 4 formulas in transverse common tangent also. O dash, and distance between them is D. Sorry. Suppose it is AB and it is CD, intersect at some point P. Now, PA and PB and PC, PO and PO dash. These formulas are important. R1 is radius of one circle and R2 is radius of second circle, and AB or CD, we call it as length of transverse common tangent, which is equal to D square minus R1 plus R2 whole square. Okay. Now the formulas, PA, point of intersection of the tangents to first circle. So that's why I have to take radius of a first circle by, since we are discussing about the properties of transverse common tangent, so sum of the radii into PA is on the part of transverse common tangent, so into length of transverse common tangent. PB, second circle, R2 by R1 plus R2 into LTCT. Similarly, PO means from the point of intersection of the tangents to the first circle center. Yes, so R1 by R1 plus R2, and this PO is on the part of the distance between the centers, so into D. Similarly, PO dash is R2 by R1 plus into R2 into D. So these are the formulas in non-intersecting circles with respect to direct and transverse common tangents. That's it. All the formulas are very, very important. Next type is externally touch each other circles. Externally touch each other circles. Externally touch each other circles means they touch externally at single point. These circles are also called as external tangential circles because they intersect at only single point. Okay. So first thing is, if R1 is the radius of first circle and R2 is the radius of second circle, then distance between the centers in externally touch each other circle is sum of the radii. And second point is number of tangents. Number of tangents are how much? 3. 2 are direct and 1 is a transverse. 2 direct and 1 is transverse. And the length of transverse common tangent means only point. So length of transverse common tangent is 0. But what about length of direct common tangent? Apply the formula of non-intersecting circles, and the direct formula is 2 into root over R1 R2. 2 into square root of product of the radii. Okay. And for suppose if there are n circles intersecting, externally touch each other like this. Okay, all are tangential circles. So if it is R1 and R2 and it is R3 and this circle radius is R4, then definitely touch each other like this, and all direct common tangents intersect at some point P. Okay, then R1, R2, R3, R4 and so on, R3, R4 and so on are in geometric progression, Okay, that means R2 by R1, R3 by R2 and R4 by R3, that is common ratio, is always equal. And what about this ratio? If angle between the tangents is theta, then the common ratio is equal to, these are equal to 1 plus sine theta by 1 minus sine theta. Sorry, here 2 theta is the angle between the tangents. If 2 theta is angle between the tangents, then the common ratio is 1 plus sine theta by 1 minus sine theta. Okay, this is one important thing in externally touch each other circles. Or suppose if I talk about the properties of externally touch each other circles in 2 circles, if I take only 2 circles, okay, of radii R1 and R2, okay, and AB is the direct common tangent of this externally touch each other circles, and there is a transverse common tangent which touch the direct common tangent at some point C, and the distance and the circles touch at point D, for suppose. Then first point, CA, CB, CD are equal. CA, CB and CD are equal. Second one, angle ADB is 90. Angle ADB is 90 degrees. Okay, angle ADB is 90 degrees. CA, CB, CD all are equal and equal to root over R1, R2. Root over R1, R2, because length of AB is 2 root R1, R2. Yes. So this is first important thing you have to learn. And second one, for suppose there are 2 externally touch each other circles. Okay. And if there is a circle inscribed between the circle and its direct common tangent, if the radii of the given circles are A and B, and the radius of this circle is C, then the relation between all these radii is 1 by root C equal to 1 by root A plus 1 by root B. This is also important. Next, when 3 circles touch each other externally like this, okay, if the radius of this is A and radius of this is B and radius of this is C, Then if I join the centers of these circles, then I'll get a triangle. Suppose ABC is a triangle. Then area of this triangle equal to square root of product of the radii into sum of the radii. This is the direct formula to find out the area of that triangle. Okay. Next. When we have three equal circles that touch each other externally, or touch one another externally like this, and all are equal circles. For suppose radius of each circle is r. Okay. Then if it is ABC, first one is ABC is of course an equilateral triangle. So what is the area of triangle ABC? Root 3 by 4 into 2r is the side. Yes, 2r whole square means 4r square. So root 3r square is the area of the triangle ABC. Second one, what is the area of this portion? Area of the portion means, I'll tell you, this portion. How do you find out this portion? Area of the triangle ABC means these three sectors. Sum of these three sectors is nothing but semicircle. So area of this portion is root 3 r square minus pi r square by 2. Next, what is the radius of this circle which bounds all the given circle or which touch all the circles internally? For suppose this is the capital R. Similarly, what is the radius of the circle? What is the radius of the circle which touches the given circles externally? And loopala unna circle. For suppose it is smaller. So radius of the inner circle is 2 minus root 3 by root 3 into R, and the root smaller తీసుకోవద్దు, is I can take it as x. Okay, radius of inner circle. And radius of the outer circle is 2 plus root 3 by root 3 into r. That is radius of each circle. Okay. So here you have to remember these four formulas: area of triangle, area of the portion between the circles, and area of the radius of inner circle and radius of the outer circle. Okay. And when we have three equal circles touch one another, same model. Radius of each circle is r. Then length of the rubber band which bounds the given circles. Length of the rubber band which bounds the given three circles is equal to 6r plus 2 pi r, or 3 plus pi into d, where d is the diameter of each circle. If radius is given 6r plus 2 pi r, if diameter is given 3 plus pi into d. For suppose there are three circles, it is the formula. If there are n circles, and not n means number of circles, n means number of circles which are bounded by the rubber band. For suppose if I draw figure like this, 1, 2, 3, 4, 1, 2, 3, 1, 2 and 1. Now it is the rubber band bounded all these circles. How many circles touch the rubber band? 1, 2, 3, 4, 5, 6, 7, 8, 9. This inner circle doesn't touch the rubber band, so you can't count this. So n means the number of circles which touch the rubber band. So how much it is? 9. Okay. So now the direct formula to find the length of the rubber band is equal to n plus pi into d, where diameter of each circle and n is the number of circles which touch the rubber band. Is it clear? Is there any doubt? That's it. Next. Suppose there are two equal circles touch each other. Okay. Now there is a square placed inside here. There is a square placed between them. If the side of the square is a and the radius of the each circle is r, then r by a is 5 by 2. R is to a is 5 is to 2. That's it. So these are the formulas in externally touch each other circuits. Next, internally touch each other circuits. Internally touch each other means they are also tangential circles, but one circle lies inside the another circle. So they are also intersect at single point only. Okay. For suppose R1 is the radius of inner circle and R2 is the radius of outer circle. Now tell me what is the distance between the centers. D equal to difference of the radii R1 minus R2. Okay. Next, number of common tangents are only one. So this is the one common tangent and circle lies on the same side of the tangent. That's why this one tangent is a direct common tangent, no transverse common tangents. And what about length of this direct common tangent? Point. So LDCT is 0. Length is 0. Okay. So here only one important model in internally touch each other circles, that is when there are n circles, okay, touch each other, touch one another, and if I draw a circle like this, that means all these inner circles are inscribed in the given bigger circle. Now what is the radius of the circle which touches the given circles like this and touches the outer circle internally? Given circles externally and outer circle internally. What about the radius of this circle? If the radius of the bigger circle is capital R and radius of the smaller circle is smaller, then radius of the smaller circle is equal to nr by 2n plus 1, where n is the number of smaller circles which we are drawing on the diameter of the bigger circle. Okay, but this is not much important, but mostly you will get like this. If two circle, on the there is a bigger circle of radius capital R. Okay. Now with the radius of the bigger circle, now I will draw two circles whose diameters are the radius of the bigger circle. Okay. Clear? Now what is the radius of this circle which touches these two circles externally and given circle internally? What about the radius of this circle? It is equal to capital R, that means radius of the bigger circle by 3. That's it. Okay, here only two circles, so what that means n is equal to 2. So here we, in the previous case, we have nr by 2n plus 1. Yes, so where n is the not number of total number of the circles. Okay, please observe one more thing. Here n is not number of circles drawn on the diameter of the bigger circle, sorry, it is number of the circles drawn on the radius of the bigger circle. Only you have to take one side. Okay, here we have to draw one more circle, 4 here, 4 here. So number of these circles drawn on the radius of the bigger circle. So here if you observe in this case, what is the value of n? It is only one circle. So nr 1 into r by 2n plus 1, 2 into 1 plus 1 means 3. So r by 3 directly. Okay, so just remember the formula, revise it, that's it. Next, last type, that is intersecting circles. Intersecting circles. Intersecting circles means circles intersecting at 2 points. Okay, if suppose O and O dash are the centers and they intersect at 2 points AB, then first thing, if radii of the circles are R1 and R2, then the distance between the centers is always equal to less than R1 plus R2, and it is more than R1 minus R2. Okay, that's why we can tell you in case of intersecting circles, the distance between the centers always lies between difference of the radius to sum of the radius. Okay, and what about common tangents? We have only two direct common tangents, no transverse common tangents. So total number of common tangents are 2, and those two are only direct common tangents and no transverse common tangents. Okay, and what is the length of this direct common tangent? Same formula as non-intersecting circles, that is equal to d square minus r1 minus r2 whole square. That's it. Okay, now we have to discuss some of the properties. For all the properties we already discussed with proofs in my paid course. Okay, so if anybody has doubt, please watch that. First, suppose there are two circles, intersecting circles. If I draw a line passing through one of the cards, one of the intersecting point, and which is parallel to the centers joining the line joining the centers O dash. These two are parallel. Okay, then definitely AB equal to 2 times of the line joining the centers O dash. This is one important property. And one more thing, same intersecting circles. If two lines drawn from the one of the intersecting point of the intersecting circles, then these two angles are equal. These are the centers O dash. These two angles are equal. If it is AB and it is CD, then angle AOC is equal to angle BO dash D. Okay. Next, there are two intersecting circles like this. O dash are the centers, and this is AB, direct common tangent, and a line passing through the intersecting cards intersecting points touches the tangent at some point C, and it is also another direct common tangent. Suppose it is CD and it is some PQ or XY, whatever it may be. It is X and it is Y, and PQ is the common chord. Common chord means it is chord for both the circles. Okay, PQ. In intersecting circles, the common chord is nothing but line joining the intersecting points. Now, whenever in this case arises, then AB square or CD square, both are equal to XY square minus PQ square. XY square minus PQ square. Very, very important. XY square minus PQ square. Next, there are two intersecting circles like here. Okay, and this is the direct common not direct common tangent. Okay, 1 minute. Suppose O dash, and C and D are the intersecting points. AB is its direct common tangent. For suppose 1 minute. AB is a direct common tangent. Now, sum of the angles made by this direct common tangent at the intersecting points. At the intersecting points, these two angles are always supplementary. If it is alpha and it is beta, total angle, alpha plus beta is always 180 degrees. Is it clear? Next, orthogonal circles. What are orthogonal circles? If angle between radii at intersecting points is 90. Here at the intersecting point, if it is 90 degrees, then we call the circles as orthogonal circles. Now we will discuss some of the properties of common chord. Very, very important, common chord. Suppose it is one circle, intersecting circle, and it is another circle. Both intersect at 2 points AB. Now, what is the length of the common chord and what are the properties related to the common chord? O dash. AB intersects the line joining the center at C. Common chord is always perpendicular to the line joining the centers. AB is always perpendicular to O dash. First property. Second property, AC and BC are always equal. AC and BC are always equal. And third point, length of the common chord. Length of the common chord is equal to, here I will write down, if the radius of one circle is R1 and another circle is R2 and the distance between the centers D is given, then length of common chord is equal to 4 by D into square root of S into S minus R1 into S minus R2 into S minus D, where S is R1 plus R2 plus D by 2. That's it. If the circles are orthogonal, then length of the common chord is equal to, it is very important, length of the common chord equal to 2R1 R2 by D. Direct formula when the circles are orthogonal. Okay. If circles are orthogonal, not only the direct formula to find out the length of chord is this, we have some other properties in case of orthogonal circles. Okay. If the angle is 90, O dash, and it is A and it is B, and it intersects at C. Okay, it is R1 and it is R2. For orthogonal circles, we have some direct formulas. Let's observe. That is, these two angles are equal. What are those two angles? This angle is equal to this angle. If it is alpha, then it is also alpha. Angle OAC equal to angle O dash A. And not only that, same as normal circles, AC and BC are equal. And another thing is, the point C divides the line joining the centers in the ratio of squares of the radii. OC by O dash C equal to R1 square by R2 square. And one more thing, the quadrilateral OA O dash B forms a cyclic quadrilateral. That means angle AOB plus angle AO dash B is 180 degrees. These are some other formulas in orthogonal circuits. Okay, and we have other formula in common chord. That is, if two equal circles are given, observe carefully, if two equal circles are given and each circle passes through the center of the other circle, then length of the common chord equal to root 3 times of the radius of the circle. If radius of each circle is R, then length of the common chord is root 3R. But the condition is each circle passing through the center of the other circle. Okay. And next and last important formula in intersecting circuits. These are two intersecting circles. AB are the centers and CD are the intersecting points. Okay. AB is joined. Angle at the intersecting points is given as theta. This angle is theta. If angle ACB or angle at the intersecting point is theta, then if I suppose these are the points D and E, then angle DCE means this angle. Okay, angle DCE is equal to 90 minus theta by 2. Very important formula. 90 minus theta by 2. If this angle is given and this angle is 90 minus theta by 2. That's it. These are the important formulas in circuits, total circuits. And next we will discuss mensuration 3D, all the formulas in 3D mensuration. That's it. Is it clear? Thank you very much. Have a good day and all the very best from my side. Thank you very much, friends. All the best for your exams. And for more PDFs, follow my blogs One is iasmathematics.blogspot.com, and in this blogspot you will get PDFs for arithmetic. సో అర్థమెటిక్ సంబంధించి ప్రతి టాపిక్ కి కూడా మీకు క్వశ్చన్స్ విత్ సొల్యూషన్స్, రిటర్న్ సొల్యూషన్స్ అనేవి ప్రొవైడ్ చేయడం జరుగుతుంది, అండ్ ఆల్ PDFs ఆర్ ఫ్రీ. And another blog is sscpuremaths.blogspot.com. So in this blog you will get pure maths related PDFs. ఓకే, సో కాబట్టి ఈ 2 బ్లాగ్స్ అనేవి ఒకసారి విజిట్ చేయండి, PDFs ఏవైతే ఉన్నాయో డౌన్లోడ్ చేసుకొని ప్రాక్టీస్ చేయండి, అండ్ దోస్ ఆర్ సఫిషియంట్ ఫర్ నార్మల్ లెవెల్ ఎగ్జామ్స్. అంటే లైక్ SSC CHSL కానీ RRB NTPC ఇలాంటి చిన్న లెవెల్ ఎగ్జామ్స్ కి ఖచ్చితంగా సరిపోతాయి. బట్ SSC CGL మెయిన్స్ ఆర్ DAO మెయిన్స్ ఆర్ SI and కానిస్టేబుల్ మాత్రం you have to watch my videos full and also purchase some courses also. Thank you. Have a good day. Jai Hind.